Hi guys, in this tutorial I'm going to solve question number 7, paper 4-3, November 2020. As shown, we have two particles, A and B, mass of each written 2 and 3 kilogram, attached to a light string passing over a smooth pulley, and the top of the two inclined planes. Given the first one makes an angle 20 and second one makes an angle 10, and the string is taut. The two parts of the string are parallel to the greatest slope, and also it's a given one of them is smooth and the other rough, P and Q. It's a given in part A, it's a given that the plane P is smooth, there is no friction force, but Q is rough and the particles limiting in equilibrium. Find the coefficient of friction between particle B and the plane Q. Look at particle B. When we try to write equation of equilibrium of particle B and equation of equilibrium of particle A. For particle B, and particle A. We'll start first with A, which it has mg sine theta. First, you have to resolve all the components of the weight. Here, the weight is mg sine theta, and this is the weight. And you have to show the normal reaction and the other component of the weight. This is for particle B and A. Now, is it written the particles are in limiting equilibrium and show tendency of motion or not? No, it's not. If you try to calculate this value, mg sine theta, so sine 20, m is 3, so this value will be 30. And the other one will be mg sine 10. If we calculate this value, 30 sine 20 is equal to 10.26. Second one, 2 times 10 times sine 10. So the answer is 3.47. So now it's clear the system, it's about to move in this direction, so it's moving up. So from the left hand side, it's clear that B, if we start from A, tension is equal to 2 times 10 times sine 10. So this answer 3.47. If we look at particle B now, all the forces, we have equilibrium, so f of x is 0 and f of y 0. This is the tension. It has tendency to sliding down, so we have a frictional force up. To write the equation, tension plus frictional force is equal to 30 sine 20. And R is equal to mg cosine 20. So R is equal to mass of B is 3. So 3 times 10, 30 cosine 20. You can find the value of R. R is equal to 30 cosine 20. So the answer is 28.19. If we go for the first equation, tension, already we have it, 3.47 plus frictional force. If we get frictional force, you can write mu R, but R is 28.19 is equal to 30 times sine 20. So from this equation, you can find the value of mu. 30 sine 20 minus 3.47 all divided by 28.19. So 30 sine 20 minus 3.47 divided by 28.19. So the final answer of mu is equal 0.241, a 3 significant figure. This is the value of mu. It's given that instead of both planes are smooth and the particles are released from rest at the same horizontal level, find the time taken until the difference in vertical height of the particles is 1 meter. First, back again to the system. Both are smooth, so I will write again equation of motion for each particle. For particle A, move up. So what is the equation of motion when it is moving up? Will be tension minus mg sine theta is equal to ma. For particle B, this is for A. For particle B, it's the same, but moving down. So mg sine theta minus tension is equal to ma. Substitute by the values, tension minus particle A, it's a mass 2, and angle is 10, 2 and 10. So 20 sine 10 equals to A. Second particle, its mass is 3 and angle 20. 3, so 30 sine 20 minus tension is equal to 3A. By adding these two equations, we will remove tension. So 30 sine 20 minus 20 sine 10 is equal to 5A. You can calculate the value of acceleration now of the system. 30 sine 20 minus 20 sine 10 is equal to, then divided by 5. So the acceleration is 1.3575. So we can write it 1.36. This is the acceleration. Now, to get the vertical height in between one, this means the first particle move up a distance and the second particle move down the same distance. I will show the system will be like this. To be the vertical height is 1. This means the first particle move a vertical height up and say this is down. The sum of these vertical heights have to be 1. Let's say this distance is x and this angle is 10. So the vertical distance is x sine 10. By the same way, if the inclined distance is x, measure of this angle is 20 degrees, and the vertical height will be x sine 20. To get the inclined distance, their sum have to be 1. So x sine 20 plus x sine 10 is equal to 1. From this equation, you can find the value of x. X exactly will be 1 over sine 20 and sine 10. This is the horizontal distance. You can, the inclined distance. You can write your answer 1 divided by sine 20 plus sine 10. So the answer will be 1.x is equal to 1.939. This is the distance, x. Now, for any particle, if we use particle A, say for particle A, initial velocity starts from 0. The displacement found is 1.939. And also acceleration found, which is 1.36. To get the time, S equals ut plus half of at squared. Displacement is 1.939. Initial velocity 0. Half times acceleration 1.36 multiplied by t squared solve the equation and find the value of t. 1.939 divided by half multiplied by 1.36 is equal to then square root for the answer. So the time will be 1.69. So the vertical height to be 1 exactly, it takes a time 1.69 seconds. That's it. Thank you.